$500 billion. That's roughly what the world has poured into AI data centers since 2022. Electricity consumption? On track to rival entire countries like Japan. Water usage? A single facility can match a city of 50,000 people. And here's the uncomfortable truth. We may have massively overbuilt the wrong infrastructure.
Wait, so AI is dead?
Interesting reaction. No, AI is not dead, but the current way we are building AI might be flawed, and that's a very different statement.
So you're saying all these hyperscaler data centers, AWS, Google, Microsoft, this whole trillion-dollar push could be a mistake?
I would argue yes, at least partially. Let's unpack this. Historically, we've seen this pattern before. Railroads, fiber optics in the 90s, massive capital deployment based on future demand that didn't materialize on time. Infrastructure got built, but investors got destroyed.
So AI data centers are like the fiber bubble?
At a high level, yes, the pitch is identical. Build now or fall behind. But here's the nuance. The technology layer is not stable yet. LLMs may not even be the final architecture, yet we're locking in billions into GPU-heavy, centralized compute.
Okay, but GPUs are necessary, right? That's how AI works today.
Today, yes, but here's where things get interesting. What if the center of gravity shifts from data centers to devices?
You mean like phones and laptops?
Exactly. And that brings us to Apple, and specifically the M5 architecture.
So Apple is killing the data center model?
Let me be very clear. Apple is not killing it overnight, but they are introducing a structural shift that could compress data center demand significantly.
Okay, now I'm curious. What's so special about the M5?
All right, let's go deep. At a high level, Apple Silicon, M1 through M4 already, was built around three key principles: unified memory architecture, UMA, high-efficiency heterogeneous compute, CPU plus GPU plus neural engine, and extreme power efficiency per watt. Now, M5 pushes this further into what I would call AI-native compute.
What does that actually mean technically?
Good question. Let's break it down. First, unified memory. In traditional systems, CPU, GPU, and RAM are separated. Data moves back and forth. That creates latency and energy waste. In Apple's design, everything shares the same memory pool. So when an AI model runs, the CPU, GPU, and neural engine all access the same data without copying it.
So less movement equals faster and cheaper.
Exactly. Data movement is the real bottleneck, not compute. Second, neural engine evolution. The M5 likely scales massively in TOPS, trillions of operations per second, but more importantly, it's optimized for on-device inference, not training.
So it's not competing with NVIDIA.
That's the key nuance. NVIDIA dominates training. Apple is dominating inference at the edge. And economically, that's huge.
Why?
Because inference is where the volume is. Every user query, every AI interaction, that's inference. If you move inference from the cloud to the device, you eliminate data center compute cost, latency, bandwidth usage, dependency on centralized infrastructure.
So instead of sending every prompt to a data center, it runs locally.
Precisely. Now, third, power efficiency. An M5 chip can deliver high AI performance at maybe 10 to 30 watts. A data center GPU, 300 to 700 watts.
That's like 10x to 20x difference.
At least. And when you scale that globally, that's where the economics flip.
So the business model breaks?
Let's say it gets compressed. Look, hyperscalers are investing hundreds of billions, assuming AI demand explodes, compute stays centralized, and GPUs remain the bottleneck. But if Apple and others push AI to the edge, then a large portion of that demand never hits the data center.
So we overbuilt?
That's the risk. and markets are starting to think about this. There's a phrase in finance, supply arrives before demand. That creates margin pressure, underutilization, and eventually write-downs.
Just like fiber optics.
Exactly.
But we still need data centers, right?
Absolutely. Training, large-scale models, enterprise workloads, they're not going away. But the growth assumptions? That's where I would be cautious.
And what about the risk side, like centralization?
That's another layer. Centralized AI infrastructure becomes a single point of failure, technically, economically, and even geopolitically. Edge AI, powered by chips like M5, decentralizes intelligence.
So instead of one big brain, we have millions of smaller brains?
Beautifully put, yes. Okay, let me try to summarize. We spent hundreds of billions building AI data centers, but the real shift might be toward on-device AI, where chips like Apple's M5 run models locally. That reduces cost, energy, and dependency on the cloud, which means the demand for data centers might be overestimated. That's a very good summary. So, the real battle is not NVIDIA versus AMD, it's cloud versus edge. Exactly. That's the core thesis. And here's my final thought. We are still in the early innings of AI. The infrastructure we are building today may not match the architecture of tomorrow.
So investors should be careful?
Let me put it this way. When everyone is rushing to build the same thing at the same time based on uncertain demand, that's usually not where long-term value is created.
Wow, okay, that actually changes how I see AI completely.
Well, that's where things get fascinating.